Hey Fixters, and welcome to today's video that is about outlier detection with NumPy. So it's a basic example of my Python one-liners book. It's in the data science chapters about NumPy, the NumPy library, and I will go over all the sections in the book in video format, so you can check out the videos, you can check out the book if you want, and follow along with the video code. Okay, so this video is about outlier detection. So let's have a look at the data first. So as you know, the challenge is, as always, to solve the problem in a single line of code. But first we need to understand the problem and understand the data. Okay, so as usual, so we import the NumPy library, import NumPy as NP. This is the standard way of importing the library. This is our data we have. Okay, so we have a NumPy array, a two-dimensional NumPy array with 5 rows and 3 columns. And now say the column data, so the first column describes the number of users of a website, for example. So you have one row per day, and now you have the number of users. So for example, on this day they had 815 users, on this day they had 767 users, and on this day they had 1008 users. The second one is the bounce rate, so the percentage of visitors that immediately go away. So this is usually between 70 and 90%, and so it's anywhere in between. As you see, the bounce rate 80%, 74%, 88%, and so on. And then you have the duration, so the session duration, average session duration, say 115 seconds or so. Okay, and here 50 seconds. So you have this two-dimensional data, and now you want to analyze the data and find outlier days for which the statistics deviate more than the standard deviation from the mean statistics. Okay, so we have a mean value, which is like you average over, so you sum up all the values in the column, divide by number of columns, which is number of rows, number of data values, which is 5. So then you get the average value, and if the average the deviation on a given day is larger than the standard deviation, then this should be returned as an outlier, if this is true for all days, for all columns on a given day. Okay, so first of all, you calculate the mean and the standard deviation. You can use the NumPy functions on the np.mean, and you pass the array A on which you want to call the standard deviation, and then you want to also pass the axis argument. So we want to calculate the mean across the zeros axis, which is the column vector. Basically, we want to sum up all these values in a given column and divide by the number of values. So we have basically the column mean, and also we want to have the column standard deviation. So we use the std NumPy function. We pass the axis argument and again set it to 0, which means that we calculated standard deviation along the columns, basically. So we have the column standard deviation here, and so if you print this, print mean standard deviation, then you see, okay, the mean average values are 811. So this is the number of users. So on average we have 811 users. This basically fits the data. Then we have 75.4% bounce rate and 88 seconds stay time. So this is the average. Standard deviation is 152 users. So plus minus 152 is in the range of acceptable user variation or user standard deviation. Then we have 7.98% bounce rate, so plus minus, so the average. This one 75.4 plus minus 8. Let's make it 8%. Bounce rate is also within the standard deviation, and then we have 88 is the average, plus minus 29 seconds stay time is also within the standard deviation. And now we want to find all rows where there is an outlier, where all these values are outside the standard deviation. And so let's do this. We have now our one-liner follows. Okay, so we want to find the outliers, and the outliers should be basically we can use the following formula for this. We use so we want to find all the rows where, so a row is a user, the number of users, the bounce rate, and the duration combination, and we want to find all rows where the average plus minus the standard deviation is basically falls outside, or actually our observed value is outside the average value plus minus the standard deviation. So we do the following. I will first write it down and then explain it. You calculate the absolute value of all rows for the first column, and then you take the first average value. Okay, so the first average value is for the number of users, so this is the average number of users, and here we use slicing to get all rows but only the first column. Okay, so this is a column vector, only the first column, which is all user data, and we calculate, like we use broadcasting basically, because now we have the column vector and we calculate minus a numerical value, which means that the numerical value will be multiplied so that it has the same shape as the column vector. So we have the numerical value, so the average, and then we calculate this column vector minus all the averages. So we have an element-wise operation where we calculate the difference, so the absolute value. So if it is negative, then we take the positive one. If it is positive, we remain the positive. So we take the absolute difference between our observed data point and the mean data point. Observed data point and the mean data point. And now we want to check, is this difference larger than our standard deviation? This means that it falls outside our range of acceptable values. Okay, so this is basically our first operation, and now, so this whole thing will return either a true value or a false value. Okay, so these are the two possible outcomes here. So we have if for a given so for all rows basically, so the result will be, because this is a NumPy array, so we have broadcasting make this a NumPy array, so the result of this absolute operation is also a NumPy array, and then we calculate the NumPy array is larger than standard deviation, it's a numerical value, but now we use broadcasting again to bring this numerical value into the same shape, so we have this, so this will be a NumPy array as well, and then the result, if something, so we have two NumPy arrays, we compare whether the first is larger than the second, so we have an NumPy array basically as a result, an array of truth values where each boolean value for each element in the ith row basically tells us whether the ith observed data point, so on day I, whether this value falls outside the standard deviation, so the mean plus minus standard deviation, and so this gives us a truth value for all rows basically. Now but we don't want to like return only the rows that have a where the number of users fall outside our acceptable range, so where the number of users is an outlier. We want to find all rows where all three values are outliers. Okay, so therefore we use multiplication, element-wise multiplication, and do the same thing, basically the same operation for the remaining two columns. Okay, so let's get rid of my face quickly. Okay, so now we have done this for the first column. Now let's do it for the second column, which is the bounce rate, and now let's do the same for the third column, which is the stay time, or the duration, session duration. And now we use the multiplication to perform element-wise AND operations. So can you see this? If you have if on the ith row, so let's have maybe a short draw board example so that I can explain it better. Okay, so we have like a column vector of boolean values. Say if there is an outlier for a given column, then we have a true value. If If there is not an outlier, so it falls within the acceptable range, then we have the Boolean false value. Now we have 3 such vectors. For each column we have one vector. Okay, so in this case, assuming that we have 4 days, and now say we have a false value here, a truth value here, false and truth, something like this. And now we perform element-wise multiplication. Okay, so we do this one, we multiply them, but it's not the dot product, it's not the cross product or so, it's just element-wise multiplication. So we multiply these 3 values, and you see the Boolean true value will be represented by the integer 1 in Python, and the Boolean false value will be represented by the integer 0. So we have, like, we multiply 1 times 0, which is 0. Okay, and here also we multiply 1 times 1, which is 1. So it's true basically. Yeah. Then we have 1 times 0 is 0, and we have 0 times anything is also 0. Okay, so this will be in our toy example, this will be the resulting vector. And it's a NumPy array as well. It's a, like, you can think of it as a column vector that indicates whether all 3 column values of this certain day are outliers. And in this case, so we want to return those values. Okay, so we can use this vector of Boolean values or of zeros and ones to use an indexing to index the elements, to index the outliers basically. Okay, so we simply print our result, we use our array A, and we pass the outliers into this array, and we use this Boolean vector as indexing scheme. So if there's a 0, then it will not return so it is a 0 at the ith value of this vector, then it will not return the ith value. Okay, so we have, for example, a 0 for the first day, we have a 0, then it will not return the first day. But if for the third day we have a 1, then it will return the third day with this indexing scheme. Okay, so it will return all indices where the this is Boolean indexing. I think we have already addressed it in the previous video. So it will return all rows where the outliers vector basically contains a 1 or a true value. Okay, and we use this multiplication operation to perform element-wise AND operation on the Boolean values. Okay, so this is quite, you have learned quite a few things here. You have learned about broadcasting. Yeah, so we have a numerical value here and a NumPy array here, and you see that you can perform element-wise operations with the minus and also with the larger equal by simply like allowing NumPy to bring those 2 vectors into the same shape. This is done implicitly, automatically. Then you have also seen that you can perform element-wise AND operation by using the multiplication operation. So there's no need to have like the numpy.and function or so, or perform use any library function to do this. You can just use simple multiplication, yeah, because Python internally represents the Boolean values as zeros or ones, so you can just multiply them. And for example, if you have 1 0 element, so you have 2 Boolean values and one of them is 0, either this one or both, then the result will be 0. Okay, and so it's like an AND operation. So only if both are 1, then you multiply them, the result is also 1. So you have it behaves exactly as Boolean AND operation. Okay, so this is our one-liner. You could write this in a single line of code, but you can also like do it like this. So it's a very concise one-liner. Try rewrite this one-liner that accomplishes the same thing in a normal way, not in a one-liner way, and you will see that it will usually take a lot of lines to accomplish this. But if you do it a smart way, if you really understand the problem and use the one-liner solution here and the learnings you had with this crisp and concise multiplication operation for the Boolean AND operation, then you'll see that it's quite efficient to do so. Okay, so let's check the result. We have printed here the mean and the standard deviation. Let's get rid of this. And our result is like there's one day that falls outside our range here, 1008, 65, 128. So it's the last day. This day here we have 3 outliers regarding these 3 metrics: users, bounce rate, and duration. Okay, so that's it. If you like studying one-liner and you want to become a better one-liner coder, check out the book Python One-Liners. It appears 2020 with no starch press. It contains a lot of valuable content, even in many different areas in data science. For example, not only data in computer science, for example, data science NumPy, we have machine learning, we have algorithms, we have Python basics. So it's like a broad picture across the computer science space that teaches you different things, even regular expressions, different areas, and gives you a overview, showing you how to use the single line of code in Python and how to leverage the power that hides in the Python syntax. Okay, thanks for listening to this video, and see you in the next video. Bye.